This is a quick look at the ORM Web tool and backing technologies. This is basically a bootstrap tool which is built on ORM itself along with the JFE model. You'll also see some TypeScript and Angular which have produced this application. So we'll look at what the tool does as well as how it's working in the back end and how those technologies can be leveraged in other places. The ORM Web tool started in, I want to say 2011 as a diagram rendering tool. This has been up on the ORM Solutions website for a long time, basically since then. It used an early version of JFE, but it didn't have all of the fun pieces in it, right? So we had the core, read and write, edit, undo, redo, stack, state change, and XML import. There was no rule engine, there was no back end, server support, no code generators, models were handwritten, etc. So anyway, that was the starting point for moving this forward. The handwritten stuff was moved to models and generated code. There was a database support was added, so you can import from an ORM model, save it in the database, update changes from a new version of the ORM model into the database. There are tools in here for TypeScript generation, XML import, other tools that are related to JFE. And reading XML into JFE and producing JSON, etc. So several of these tools are stock. They're part basically of the JavaScript of the JFE Angular libraries, just applied to this model. So these can be applied to any model for good parts of this. So the be all end all of this is we really want to be running some sort of application from the ORM model directly. And you can actually see that in action with the XML import, which we'll show at the end of the presentation. So the first workflow we'll look at is a basic save or import a textual ORM file into a database. Then we'll look at getting it back out. The import is done with a recording mechanism. So once we have the model imported with the XML loader, we were able to take that, clone it into another fact base with a recording in place. That gives us a diff. We don't record things or export things like connections and pieces that aren't actually stored with the model. Those aren't stored in this system either. The major operation that happens besides the database write is the IDs are changed when we do this. So the IDs in the model file itself are a bunch of GUIDs. But you can load the same model in both times, so we can't really use those GUIDs as the primary database identifiers. So as soon as the model is loaded into memory and onto the database, we get a return that says, well, these are the old IDs, these are the new IDs. At that point, all of the temporary local identifiers are obliterated from the system and replaced with the permanent identifiers. That means the undo redo stack, anything that you have in JFE, you can clear out all of those temporary identifiers. So this write is done with 100% generated code minus the few lines of routing which help that get into the application through the web server. However, the read here, I will admit, is optimized. The hierarchical queries that we generate, we're just a little too slow on this. The relational mapping layer is very good at getting all of the fact types for a model. That's one round trip query to the database. However, then you have 500 fact types and you need to get 2 or more roles for each of those fact types. That's 500 additional queries to get the 1,000 roles. And if you want to do something with the roles, it blows up from there. So it turns out that a whole bunch of very small queries to the database aren't very good, but a small number of larger queries are much better. So there are hooks in there to say, well, I'm replacing this part with another part. And that is done with handwritten DQL. DQL is doctrine query language, which is working in a RDBMS agnostic mechanism, so it doesn't care what the backend actually is. This is running on Postgres, but it doesn't matter. And then that is written directly to the JFE. But the original, JFE query spec is used basically as the reference implementation, so we know what the JSON looks like. We can get the data back this way. So a whole model, regardless of size, comes back in about max 50 queries, depending on which extensions you have on in the model, which is really good and it's really fast. It's also boilerplate code. I'd really like to generate this pattern. It's tricky, but it's very much repeated code and boilerplate code. I think I added about 1,500 lines of code total, which really isn't bad for a, this 50 to 55 table application at this point. And you'll see that the database performance is really, really good on the read. So as a tool in progress, we aren't pretty on the home screen. This is just links to different capabilities here. This is an Angular application. So this is a SPA single page application that's basically compiled on the back end and produces a bunch of JavaScript for you. So the first thing you can do here is open ORM models. Your new model from file is always available. These are models that have already been loaded into the database. You can actually see the load speed. I mean, that's really quick. This is a big model. This is the working group model we did for ORM standardization a few years ago. Looks really good. It's SVG. It's very cleanly rendered. You can individually pull the diagrams up. It's actually a much cleaner rendering than you'll get in NORMA. This is exactly the same engine that's used in the NORMA Pro Word report to produce the SVG. The file's unchanged. One of the core files is pulled out of here. Okay, so let's choose a different file. It's actually, I'm going to go back home so it doesn't prompt me to update that one. I'll just say new model from file and choose a file. And at this point, we're going to go to the ORM JFE. This is actually the main model ORM file that is used to implement this application, right? So this is the in-memory model here. But we're going to pull this up. Notice it's a little slower on the XML load, but still fairly reasonable. But before we upload this, I want to take a quick look, peek behind the curtain, and we're going to look at the fact base. So in this particular application, there's a global object called ORM viewer.view, and this will have a fact base on it, and we can look at the elements in the fact base. Okay, so these are organized by type. ORM is the core ORM model, DIA are the diagrams, ORM DIA or ORM diagram components, obviously. CP is custom properties. So if we look in here and look at, for example, all the ORM, this is the whole model in place, you'll see all the identifiers, right? These come straight out of the ORM file, right? And here we have the file IDs. So this gets interesting. The file ID is just a copy of the original identifier. So now we're going to upload this file. Okay, so this goes up to the database, writes to the database. Again, this is the process to do this is 100% generated code. It's not super fast, but we're writing a mass, really a lot of data when we're doing this. As soon as you get a model number, you may not have seen that. It goes from view model to view number model with a model number. Now we're going to get different data in the database, right? As I said, we need permanent identifiers. So at this point, it's the same fact base. It hasn't recreated it, but it's applied re-IDs on the whole thing. So now our ORM model is 68, right? And here's the file ID. So this GUID identifier right here is gone. Okay, and that's now considered an artifact that's just gone. It was a local identifier. We're no longer using the local identifier. So that's the load save mechanism. So if I reload this, if I go home, pull my model list, we'll see this model has come back in here. ORM JFE, notice there are two of them, so it's actually loaded this file into there twice. I can click that, and I get a really fast read back out of the database. Very, very fast, regardless of model size. So there's our load and save workflow. So now we have a file uploaded into the database. We want to be able to take it, change to that file, a new version of the file, and modify what we currently have stored in the database incrementally. We don't want to upload the entire file every time. So this gets a little more work on the client, but is a very small amount of work for the server because you get smaller change sets. So given two models, I've got a fundamental problem to begin with, right? My model in the file, that's the updated ORM file, has different identifiers now than the one in the database, right? However, remember I kept those file ID values. So the first step under recording, right, is we take the saved file and we swap the file ID in the ID fields. So now the primary identifiers are the original identifiers that we had in the file. At this point, again, this is with a recorder on, we take the new file and simply load it into the same fact base. Now JFE is a fact engine, right, which means that when you're stating a fact is true. So when you say get object, you're saying this exists. Doesn't care if it gives you the existing one, or if it creates a new one. You don't know, you don't really care. But in this case, since I'm loading the same object in with the same identifier and same type, it says, well, nothing happened, just give me the object back, right? So the load, it tends to be fairly small. You get a small diff out of this. That gives us the additions and deletions. I said that wrong. That gives you the additions and changes, right? It does not give you the deletions, because the things that are in the original file that are not in the new file, you didn't get that by recording a load on top, right? So that takes a little more work. So we'll get to that next. So at this point, we take get the deletions, and then by the time the state change is over, we restore all the IDs at the end, which clears them. Remember, this is a state change, so it goes from the beginning. If you make a change and then you change it back, there's no net change. The history is gone. And when we're done with that, we actually have a state change object that tells you what the differences are. Okay, so to get the opposite, we simply reverse the process. We load the new file into a new fact base. We take the updated file at this point. The little star there gives us a file with the new IDs, or sorry, the original IDs, and the deltas in there. And now we load that on top of the new file. So that gives us another diff, which is the additions and deltas going the other direction. So we strip the deltas, we get, which will be just the reverse of the other ones. We get the additions only, and now you subtract that from the original set. So essentially you do an undo instead of a redo. That gives us our minus. That fills back in after they apply the minus. You restore the IDs, detach the state change, and you now have an object that you can set back to the server. So notice there's absolutely nothing in here that's domain specific, right? Apart from the fact that I use the file ID property instead of to store that original identifier. This is a process that could be applied at any point. It's been really nice working with the ORM tool, because when I make an addition, so for example, if I add relational model in here, or the derivation rules, and round out the object model that's available in the ORM file, I have no additional code to write here at all. It just works. So this can also be done on import, obviously, from other systems, and use this pattern. So that's what's going on in the back end. It doesn't look super fancy. You load a new file and it says, hey, update changes, but this is what's happening in the back. So it's actually loading the new file twice, getting a diff both directions, producing one state change object, and sending that to the server.
So let's look at a small incremental change here. We have the same model we had up before. I made a copy so I don't mess with anything important. Object type is partially derived. Let's just rename that as partial derivation. It means the same thing, slightly different. Okay, now we're going to save that and reload it up here. We'll first check that the model identifier, the GUID in the model file, is the same. If not, it will say, yeah, we're not going to merge these. Because that identifier is different, the rest are going to be just as bad, so you're really not going to get a merge. Okay, so this loads it in, does the plus, minuses, deltas, changes, finds a change, and now before uploading, I'm going to hit the network so we can actually see what got sent. So we have fetch XHR on, and let's send this change back up to the server, upload changes, got a quick write, status 200, and this is what went up. So if we go hit the object type tab here, you'll see it says has partial derivation. Okay, so we have a before and after change. The after is well, that's shape size. I need to be an ORM. Obviously the shape size changed. Object type has partial derivation. That's on object. You also have the change in the predicate reading. There's a implied object for the unary, which has that name on it. So we change to that. Now, if this text property is in both change branches, you get a before and after. So this means it's a change because it's in both places. So it changed from here to here. And similarly, we can change back. Let's undo, save, just to verify that it's actually up there. Go ahead and reload that. And click object type. So we have the old, or the temporary has partial identification. Let's go ahead and pull that back up. Okay. Get our change. Upload the change. And now this will immediately change back to his partially derived. So that's the incremental change code.
Just for fun, I'm going to give you a small sneak peek on this is an editing tool as well. There are very few edits that are actually enabled, but you can see essentially what's happening. You can see the undo redo stack in JFE. You can see diagram interactions and shape interactions.
So this Angular app actually has some older files behind it that were standalone files without that. So if we do this, ORM model ID equals 68, we'll get the same thing back without the Angular wrapper. So this is just what you saw before. You can navigate, you can select on other diagrams, the normal model viewer. But if we go into ORM edit, you'll see the only difference is we have this. Okay, the undo redo stack isn't visible, but it's there. Let's go in and look at reference mode. And we can take this. Oh, missed the drag. The string's doing weird things with the recorder. And we can go ahead and add that uniqueness. Let's place it a little better. Let's rearrange this and do that now. Notice this is all on undo redo. Control C, Control Y until you go back to where you were. It's about what it does for now, but that's a good start. The diagramming surface is clearly capable of taking the edits, and we'll clearly add more gestures as we expand this.
So the TypeScript interface generator is a easily plugged in tool. It goes ahead and reads the actual model space. So this is not looking at the ORM model or any other definition of the JFE. It's looking at what is actually in memory and then reproducing the objects that it's creating. So the JFE objects don't actually exist. They're declarations. There's no like class or function if you're into older JavaScript with public methods and properties and all the things that you get now in your component definitions. It's just declarations. Here's a list of the properties. Here are the links that we put in there for you, and that is very difficult to access from TypeScript because there's nothing there. So what the interfaces do are provide something TypeScript can look at. This is compile time only. There's no runtime overhead to do this. But if you do this in NORMA Pro, which also generates most of this file, you can only do it for one model, right? Because the NORMA generators are limited to a single model. It doesn't do anything cross-model. So here it will go cross-model, and you can pick what you want. It also creates a bunch of interfaces, what I call the type fact base, which is a way to write to the JFE model using compile check code, right? There's a very small amount of runtime code to support that. In the back end, I think it minifies to less than 3K. It's very, very minimal and fast.
So the tool for the ORM itself can be opened here. This theoretically can also let you get at your ORM code. So you can interface with the objects that are stored on the backend database for this, using the same service and the same mechanisms to pull the objects. So the ones that are unchecked are dependent. This is for dependencies. So for example, ORM dia depends on dia. So if I start unchecking things, I can get quite a few things off here. So those depend on JFE def, ORM ref, XSD, ORM index we may not want. So this is back to what's originally in the ORM JFE model. Right, the index is declared on load, So that gets added in here. So you get additional files in here. So this is the contents of, I believe, 3 ORM files. So they're all available here. If I do a copyright here, you can see the generated fact base mechanisms at the end. That's on the clipboard. Let's go somewhere and look at it. Okay, so you get things like this. This is for each link. Right, so this means I can do particle would be, this is the XML model, so I can do typefactbase.xml.links.particlehost, and then I can do get linked and get linked, which would create a link if it's not there, is linked, delete linked, etc. Modify the fact base by doing that. And these get just named arguments in order as opposed to string collections that you need to populate to do this with the core JFE API. This is actually much easier to do. So your types, you have a type. The type you can pass to an instance of if you really want it, or you can just say try cast. That will actually verify that you're in the right shape. And these are all mapped directly to the JFE API. Props is a nice little object. You send it the instance you want, and then you can set and get and set properties as you will at that point. So anyway, this is a lot of code because it essentially repeats the API for each object type, and then the interface API for each link type. But it's really nice to have. I'm doing all of my coding with this now. I'm not doing any straight to the underlying API anymore.
Next, we get the query builder tool. So the queries on the back end are done declaratively with JSON. You specify link names, type names, property names, and you get the data back. You have 2 parts of that. One is it's called a closure, which is how do I navigate from object to object, and what do I return in the JSON when I get an object of that type. And the other one is a root IDs, which is similar in structure, but instead of returning what you get, you give starting identifiers. A null there means everything. Otherwise, you have an array of identifiers. This is part of the Angular stack, as was the previous tool. So these are just you can just plug them in, basically. They're easy enough to plug into your system. So what this lets you do is if you have an endpoint, you can actually go back and read that. So this assumes there's an endpoint I can read to. It sends in the request. The request has a closure and root IDs, JSON section, and applies this to the server. Whether you want this wide open on your application or not, outside of a debug environment, is completely up to you. This lets anybody get any data, but this is the body of the request. So we get the content, get the JFE IO, which is the generated code. Expand closure essentially binds what you asked for to what's available, and then the get closure JSON actually does the query. The true says return in string form, which goes straight into a response object. So that's all the back-end code I need to support this, but yeah, you do need something on the back end actually to interface with the system.
So that's the JFE query tool, just that click there. What this shows you is what you can get. So these are all, again, the models that are in this defined in this model space and fact base. Here are all the types per model. So if I go, for example, here to the ORM model, and this tells me what's available with that model. So now I can go in and start building this out. And say ORM. We can say, notice that the red means you don't have a valid JSON file. And then you'll get into yellow, which says, well, you don't really have anything I recognize on there. Okay, so this is asking at this point for, should not have fewer than 1 item. So there's a JSON validation that's supported by this tool. So this says, when you get the ORM model, just give me all the properties. All right. And similarly over here, I can say ORM model, oops, and we'll start with null. Okay, and that clears your JSON, so that's also valid. Okay, so at this point, I can execute the query. And here's my result JSON. This is what comes back. Okay, so 1, 2, 3, 4, 5 models. Okay. Let's get the one we put in. So that's ID 68. So there's nothing else back here at this point, just the models. You can also go into the browser and look at your model instances. This takes you back and forth through your selections as you navigate. That's also a JFE object. It's a separate fact base. Okay. So now you can look around. Now there are some auto loads and things that happen when you load an ORM model. These are still in the model space. They're part of the models. So you actually get more automatically than you got with just the JSON coming back. Okay, so let's narrow this down a little bit. We're just going to go to 68. Okay, so now if I run this, you can see I just have the one model available, not all of them. And this says on my available closure directives for ORM model, I can do, let's see, object type. Model has object type. So this is the first slot, which is blank here, is the model name. So if you have an external model, you can go there. This is the link name. This is the role played by the local object. So let's go ahead and copy that onto the clipboard, which is helpful, and paste it in there. The yellow goes back away. We're able to see that. And we'll go ahead and add something for object types. Let's get the properties again. Okay, that's all properties. You can also subtract properties. So I go to object type. That gives me an idea of what's coming back. Right here are all the properties. So you can say $, but don't give me, for example, the file ID. Right? Okay, so this will go from the ORM model, pick up all the object types, and fill in its properties with this code. So here's your JFE browser. Now look, we have a bunch of object types as well. All right. So quite a few object types, right? Plus the Boolean values, names, kinds, and you just build out basically like this until you get the data you want. At that point, you can go back here and copy the PHP, which will then go into your backend. Or you can just leave the query tool wide open and keep your direct query controller. Anyway, this is great for figuring out and live testing how to get your queries back, so you don't have to like put code in the controller and edit it and try it and go back to your front end. You can just run all of this right here. But when you're done, you can put that on the clipboard, right? So this will be PHP closure JSON on the clipboard, which looks like that, which is what JSON looks like in the PHP. So the ORM analysis is a new part of the tool that I've been working on. This is really starting to be a tool bench for things you can do with the ORM models, especially some of the NORMA Pro extensions. So the first thing you can do is run your TypeScript interfaces for a JFE markup in the file directly from the ORM model. So this is done with a JFE def, which is actually a JFE model that describes JFE itself. I've said JFE a lot there. But it's not doing code generation. It's not loading the it's not creating a JavaScript file to do this. It's done dynamically. And you're actually side loading a second model space. So in the ORM tool, you have a fact base and a model space that has ORM, and the other parts of that are in the ORM model, like a hierarchy for XML, and this creates a completely parallel model space. So the way it does that is this JFE def model contains the JFE model, and that has a create model space function on it, which takes the JFE models that were out of the ORM file and produces a new model space for them. So you're basically side loading a separate application. XML schema is done separately. There's a different schema model that is parallel to the ORM JFE model and the JFE model .orm file. And so if you have a NORMA Pro hierarchy with schema information in your model, we can create the schema for that as well. So here we're in the tool. You'll see up here there's an ORM analysis button. If I hit JFE interfaces, I have a slightly different set than I had before. This is less. Why? This is pulled directly from the ORM model, which creates a new fact base. This tool actually runs off the fact base or the model space, not the instances, the types. So that doesn't look much different. But if we pull in a different file, actually I don't want that. I pulled in a come on, send me home. I pulled in a file that has XML and JFE information in it, so we can see more things here. Okay, so good sized file, right? A lot going on here. We can do an ORM analysis, pull JFE interfaces, and now you see you have a completely different set of interfaces of JFE models to choose from. So again, this is not running off the model space that's loaded globally with the tool. This is running off a side-loaded model space. And it works the same as it did before. So you also have a schema dialog here. These are the schemas defined in the model. And you can copy or save the schema. And here you can, same XSD that we generate in NORMA Pro. It's actually exactly the same. And these two forms have been used to improve each other, as I found a few inconsistencies and fixed a few things on both sides to make that work better. Okay, so with those two now, the next step will actually get into importing XML into JFE. I'm going to go ahead and show that now. So, and then we'll talk about it on the next slide. So here we have an XML import. Now to say we're actually going to successfully import this is pushing it a little bit, because it's easy enough to import to a new database, but usually you'll have some elements that are already represented in the database, and to do those you have to import your XML, examine it, pull back the pieces that you want from the database, and then load your new data on top of that so you get a clean diff. So for example, in this case, the mission isn't going to change every time you do an XML import. So you'll look at it, say, what mission am I importing for? Get the data back for that mission, so you don't get an add, which of course is going to cause problems on the database side. JFE doesn't care if you add duplicates, but the database absolutely does. So anyway, the import is maybe pushing it a little bit. You also have CORS issues, so you actually need permission from the other website to push data to it. But here we have a file. This file is known to be, where did I go to here? Is this, oh, there's an other, there's my file. Okay, so this is the more recent one. And let's open that. Okay, so several things happen here. It loads the file in, does an error validation. The only error validation right now is the simple mandatory constraints. It's basically a proof of concept, but still very, very useful. If you actually give it an endpoint and upload, you're going to get a 500 error, because you're going to have database validation errors all over the place. But if you had a clean error, this wouldn't show up. But because it does, we can click here and we can say, okay, well, the entity object has a missing mission. And again, this is a generated error spec that's built on top of the existing models. So you attach this, you attach the mapping spec, which tells you how to map the XML to the JFE. And these are all coming in as JSON blobs. So I can take the JFE def JSON, load a global model with just JFE def. On top of that, I can create a new model space with the defined JFE models. And then I can attach my XML mapping, and I can attach my error validators. All of these are generated pieces, and they can all be stored in JSON, which means it's very easy to load this into a separate environment in a separate file. So the import JSON, this is just a small blurb on how you could use it. Looks like this. That's not very useful. Let's go ahead and just go into Visual Studio and grab a new is there a JSON file somewhere? Web JSON file. We're going to paste that in. So this is your specification that was generated off those two pieces. So we know the JFE, we know what the XML schema looks like, and to read this XML schema, this is what you get. This will actually do all of the schemas, right? So it's keyed by the root namespace name on schema file. So this tells you where to start, how to get properties, how to get links. There's a lot of information here. Notice you've got XPaths and then targets. So NBSC activity involvement description property, right? So this is JFE information. This is XML information that's rooted on this other object. So this spec can now be pushed in, and this is what actually did the XML read directly into the JFE model. That produces a state change. If it's validated, you can then go ahead and push that up to a server endpoint. So clearly this makes more sense integrated into an app that has a little more domain-specific knowledge in it. But it's still really cool technology to be able to get this far.
So what I want to emphasize on XML import is that this really is a side-loaded application. This is based 100% on the ORM model. There's no data coming in from outside the ORM model. So I can get the XML schema, I can get the mapping information, I can get the JFE model, I can produce a bunch of validation errors. Those can all be saved as JSON blobs or loaded from the error objects, but with that information I can now create a completely separate model space, isolated rules, isolated models that have nothing to do with my original app. I mean, this is not ORM data that you're looking at here. And clearly the implications on that are, as we continue to work in this project, you can get more rules, you can get, we'll be working on the derivation rules, so start implementing those and really get a real app framework in place, including being able to produce API on the fly or UI on the fly that we can look at and live validate a model. So think about a sample population editor that has a pretty page and really has its full validation on it. I mean, that's where this is going, and it's moving there pretty quickly at this point. I mean, the JFE technologies really enable this. I'm able to look at these pieces in memory, analyze the ORM model, extract a lot of data out of there, and do an awful lot of work based solely on that ORM model, right? And again, there are no code generators here. This is just producing JSON and loading strictly from that data that's produced from the ORM model. So to wrap this up, I just wanted to, talk about where I'm planning on going with this. I think the priority for me is definitely application generation. I'm trying to get the ORM model implementable first. I mean, I have an editing tool with NORMA Pro, so I'm not as anxious to get the editing parts done, but I would like better verbalization, model browser support, be able to view around the model, and then we can move into other model parts. There are a few pieces of the ORM model that are not imported into this tool, but the main focus is being able to really get the ORM model running. So we have a back end, we can store the data. You can see this is already a fairly complicated piece of software, right, that's doing all of its data management through this generated back end into a generated database using a generated model and transport layer and a very small, fairly lightweight framework that's doing the client work to enable this. So that's where we're going with ORM Web. I hope you've enjoyed the presentation. Thank you.